Alright guys, today we're going to be doing a brief synopsis of chapter 13 section 2, which is limits and continuity. So this chapter has a lot of similarities to Calc 1 in that it's literally the same thing, but instead of viewing limits in 2 dimensions, now we're going to jump into 3 dimensions. So first things first, let's define continuity. So for a function f of x to be continuous at any point x equals a, one, the point must exist, meaning there can't be like a jump discontinuity. The limit must also exist. And the limit of f of x must equal the limit of f of a. So these are the 3 conditions that are necessary for the continuity of a function of 2 variables and 3 variables. Then the next concept is bounded versus unbounded functions. Looking at this function right here, we can see that it is bounded. And what we can define bounded as is if your function can be contained in a circle of any radius, then it's considered bounded. So if you have any function that approaches infinity, either negative or positive infinity, it's unbounded. Let's move on to this graph right here. It kind of helps you visualize what the essence of this chapter is, because when looking at limits in 2 dimensions, we're approaching from both the left and the right. And if you see a discontinuity there, then you know the limit doesn't exist, meaning that, I don't know, if I'm coming from the left and the function hits 2, and if I'm coming from the right, the function hits negative 2, I know it doesn't exist. But in 3 dimensions, it's a lot more difficult to visualize because there's an infinite amount of directions you can come in from. So looking at this graph right here, you can see that coming in from one side, you're going to a completely different point than when you're coming in from the other side. And this happens for every single direction you're coming through. So that's the biggest difference from this chapter to what we did in Calc 1. So to kind of visualize this was the graph, but now let's dive into an example. When we're solving limits, the process is almost identical. You're going to plug in your points, and you'll get some number that'll give you the limit. And obviously that's pretty easy, so I don't think I need to show an example. You just plug in the x, y coordinates and you get your point. But when you're plugging in x and y and you're getting double zeros, that's when there's some other things that need to be done. So what you're going to have to do is you're just going to have to factor the denominator or something of that sort and cancel them out. So solving the limits is pretty self-explanatory, but the difficult part is proving that a limit doesn't exist. Because as we talked about, in Calc 1, you could just say that the limit from the left doesn't approach the limit from the right, or isn't the same as the limit from the right, but it's different now. So let's look at this function. We have a function f of x and y equals 2xy over 3x squared plus y squared. And let's try and prove that this limit doesn't exist at 0, 0. So what we're going to try and do is you want to take, obviously there's an infinite amount of directions you come in from, but you want to just take 2 directions and prove that the results are different. Proving that those 2 limits are different will allow you to generalize that the limit doesn't exist. So for this first function, let's start off by using y equals 0, because the point is at 0, 0, so we know y equals 0 exists at that point. So plugging in y equals 0, you get 0 on the numerator and 3x squared on the denominator, but obviously we know that equals 0. So coming in from this line, our limit equals 0. But let's now try and come in from y equals x. You're going to get 2x times x over 3x squared plus x squared. And simplifying that, you're going to get 2x squared over 4x squared. And what that's going to equal is 1/2. So what that shows you is that at the same point, when you're approaching from 2 different directions in this 3D figure, you're getting to different areas, which is basically a proof that your limit doesn't exist. Because in order for limit to exist, you need to hit the same point from all directions you're coming in from.